Okay, so for this practical, it says heat strongly until no further change is seen. So we must think of decomposition. When we look at the observation, so white solid turns yellow-orange when heated. Then we will think, could it be zinc? Okay, however, zinc is yellow when hot and white when cold, but they never say anything about leaving it to cool heating strongly. Okay, so it may or may not be zinc. And the next part it says test for any gas evolved using lime water. So we must think of is a test for carbon dioxide. So if that is so, white precipitate is formed in lime water. So if there's carbon dioxide gas, that means that likely there is a carbonate ion present. Okay, so carbon dioxide gas will give you your white precipitate. Okay, so which means that during the decomposition, in this solid X itself, there is carbonate ion. If you are unsure about the decomposition, refer to your notes. This is an example, zinc carbonate, okay, all the observations, and this is page 11 of your notes. Okay, for this part, it says add dilute nitric acid. So we're talking about acid, we need to think that it could be acid with metal or metal carbonate or base, as that those are the acid reactions. And you also need to test for any gas. So you need to think what gas could be evolved when acid react with either of these. It could be either hydrogen gas or carbon dioxide gas. Okay, so firstly, when we add nitric acid, you see effervescence, which means there is a reaction. Okay, and then what gas is produced? So there is a gas that is produced. So since there is a gas produced, we describe the color and the order of the gas. And finally, it says to dissolve. So we say whether solid X dissolves. And if it dissolves, what kind of solution does it form? And so that's the first part. And so because it says test for any gas evolve, and there is a gas being evolved. So we are guessing that it could be carbon dioxide gas. So we use bubble the gas into lime water. The observation is white precipitate form. And they ask you to name the gas. So we have to name the gas in this case. So carbon dioxide gas is evolved. Why do we test for carbon dioxide? Because in the previous one there was carbonate ion. Okay, so we are predicting that this carbon dioxide gas is produced. Okay, so after the solid X has dissolved, we add water. So when solid X dissolve, if we assume that it is perhaps zinc carbonate reacting with nitric acid, we may get zinc nitrate, water and carbon dioxide gas. So perhaps this solution that we have now after dissolving could be zinc nitrate. Could be. No confirmation yet because there is no cation test yet. Okay, so for the next part, see part 1, it says barium nitrate. So earlier on, it already said to add nitric acid to dissolve the solid X, which means we have acidified this solution. So it's as if we have added the acid and now we're adding barium nitrate, which means this is a test for an ion, which is sulfate ion. Okay, you can, if you are unclear, you can refer to the note, to the practical sheet that they give to you, and it does say test for sulfate ion and that you may get a white PPT. But in this case, no precipitate is formed. You can say either of the observations, no PPT, solution remains colorless, or no visible change. Okay, this statement is missing, so please copy down. So it says sulfate ions is absent because the missing one was record your observations and conclusion. Okay, for this next one, add few drops of aqueous sodium hydroxide means it's a test for cation. So test for cation, if you refer to the practical sheet, you always say what color PPT is formed. Then only if they say add aqueous sodium hydroxide until no further changes are seen. This means you must add an excess. Then you say whether the precipitate is soluble, and if it's soluble in excess, say excess what? Excess NaOH aqueous to give a colorless solution. So please give complete statements. Okay, and with this observation, we can make a note that is perhaps lead ion or zinc ion that could be present. Okay, for the next part, it says a few drops of aqueous ammonia. So again, test for cation. Okay, so test for cation, if they say a few drops, we just say what PPT is formed. So white PPT is formed in this case. And if they say next to continue adding until no further change, which means in excess, that's where we say whether the PPT is soluble or insoluble in excess, aqueous ammonia in this case. Okay, so all your observations is written in black. The ones in red is just your own pointers. So here we can conclude that there is no zinc, but instead it is lead. So what we had was lead cation and not zinc cation. Okay, the last part is the hardest. It tells you to add aqueous potassium iodide, and what you see is a yellow precipitate. And they ask you to name the type of reaction. Okay, and here the reaction is called precipitation. But how do we know? So first of all, when we see potassium iodide, we will think of two things. Either one is a displacement of halogen, where the group 7 halogens displace iodide from this salt, or it could be precipitation, where two soluble salts react together. So in this case, the two soluble salts is lead to nitrate and potassium iodide, and what you get is potassium nitrate and lead iodide. So lead iodide is your yellow PPT. Okay, which is why when it's a soluble salt reacting with a soluble salt getting an insoluble salt, we call it precipitation. For the conclusion, they say suggest with evidence the identity of the anion present in salt X. So anion is a negative ion, and with evidence means you must refer to the practical parts. So if you refer to the practical parts, when they talk about solid X, you can see two parts referring to solid X. Part A, where there's decomposition, or part B, okay, part A where there's decomposition, where they say that carbon dioxide gas is being produced. So that's where carbonate ion is present. Or in part B, where solid X reacts with nitric acid, and therefore giving carbon dioxide gas as well. So either part A or part B will tell you that carbonate ion is present in solid X. So with that, we know only part A and part B tells you about solid X. So the anion, remember to write the word ion. So you can write under the chemical formula of carbonate, or you spell carbonate, and remember to write the word ion for both. So the evidence can be written in these two ways, either part A or part B. This is a rather simple form. Usually part A we will add in decomposition.